Hi, my name is Sable, and welcome to my presentation. Um, the presentation is, as you might have gathered from the title, called My Malware Skills Are Getting Rusty. Um, if there was no description, or it just hasn't been posted, or maybe you didn't see it, this presentation is going to be about the use of the Rust programming language in terms of malware. Basically, has it been used? How would you use it? And why might you use it? Uh, Thanks for being patient. It is my first talk, and I did have to pre-record this because I wasn't able to make it to any of the talks. Um, I just want to make it clear before I start, I don't condone actually making viruses for any reason other than learning, nor should you ever use them on anyone. If you make any, use them on yourselves in a controlled environment. And yeah, sounds cheesy. Without further ado, let's get into the presentation. So what is Rust? For starters, it's not the game, although that is a cool game that I'm sure some of you are a little too familiar with. We're not talking about the game. We are actually going to talk about the Rust programming language. You may have heard of it before. It's gaining popularity, and in Stack Overflow surveys, it was being rated as one of the most loved languages. Um, and it's what people want to rewrite parts of the Linux kernel in. So we'll move on to exactly what it is. It's a memory safe programming language. There's a little thing on the side so you can get a little bit. I'll show you a little bit more later. It's a memory safe programming language that, when compiled, produces a small binary size. And yes, it's compiled and it runs on native code, so you're not using something like the JRE to run bytecode. It has speed that rivals C or C++, for the following reasons: because it uses LLVM under the hood, and LLVM stands for Low Level Virtual Machine. The compiler is very aggressive. It performs aggressive optimizations and can get even more aggressive when you allow it to. And it is very strict with what it allows. It doesn't even let you use certain naming conventions unless you disable those warnings. The compiler also works with custom linker scripts and any LLVM target that there is. And LLVM is obviously, like I said earlier, low-level virtual machine, and it provides an intermediate representation, which I'll show you in a bit, of what code is so that it can be compiled to any platform. You may guess what that will be used for, and we'll talk about that later. But what does some Rust code actually look like? Right now I'm just showing you some of my own Rust code. It's nothing too big, nothing too important, but it does demonstrate some of the interesting syntax that Rust may have. It has things called macros, which you can imagine as macros in C++ or macros in C. It has interesting syntax, as you can see with the pub create on the function getBanner. And you may see a lot of dollar signs, a lot of exclamation points, and normally in Rust code, you'll probably see a lot of colons as well, but you don't see them as much here. Pretty simple language once you get used to it, but it is rather complex and daunting for beginners with a steep learning curve. How can this actually relate to malware? Well, that's a good question. Currently, most malware is being written in C or C++, very popular languages. C is what makes up the Linux kernel, and C++ is what makes up a large portion of other kernels in a lot of applications where people worry about binary size or embedded applications where they have limits on a lot of things. Rust has a low overhead because it's not a garbage collected language, but you're also not managing memory yourself. It's ownership based, which, long story short, means each variable has an owner, yada yada yada, that can't be breached except for certain ideas. Anyways, um, it's unique compared to most languages and allows you to write complex code safely and easily, and it can get very low level. Um, and if you need to get any more low level than it already can, which you shouldn't have to, you can use something called unsafe, and you can even use inline assembly, just like in C or C++, although that does obviously expose your program to being unsafe. Um, Rust utilizes LLVM, like I said earlier, meaning it can easily be cross-compiled to any LLVM target that has been adapted by the Rust team, which is why Rust is being currently used in some embedded projects, as it can go to any x86-64 platform, x86 platform, it can go to ARM, it can even go to the new Apple M1, it can go to a lot of things. It's also memory safe and can help avoid common bugs that strain common programmers. Can also make things a little bit easier to program when you're avoiding those bugs, making it faster. Why would I want to use Rust? Well, when you use the Rust, it'll change the signatures because it's different. Obviously, I mean, it's going to change the signature because it's not the same. So the signature isn't going to be in the antivirus database or whatever they're using to recognize it. It can also make your virus more secure in terms of like you're not going to find any paths laying around in the executable. Those will be stripped. You can make your strings not be built into the executable, so you can't just grep an executable. It can also speed up the production of viruses with it being write once and then just compile to any platform you want. And it can pretty easily make your virus cross-platform with layers of abstraction with no real sacrifice on speed or binary size, although there have been a few issues with embedded development, but usually that's not a huge concern for virus developers, unless for some reason they're targeting embedded systems, maybe cars. I'm just showing you a little bit of what this looks like. On the left, you will see the intermediate representation. On the right, you'll see a hex editor, and yes, I know it's a PNG that it's disassembling. Just bear with me. I couldn't find a clean photo of Rust, and I didn't have Rust on my device when I made this. But you can see that everything looks a little bit like slightly more complex Java bytecode, but it's not very machine dependent. And then the triple is what tells the compiler after the IR on what to target. So that means if you save the IR, you can recompile it to anything you want. Very nice. And then on the right, you'll see what hex code would look like. It would look pretty similar to that, probably with less zeros, and you might see some more strings in the PNG. I mean, in the program instead of the PNG. Overall, not a huge difference. But so what? What does this actually mean? Well, to a lot of people, it probably means almost nothing. But for those that, well, it does obviously mean something. It means that the viruses can go cross-platform very easily, which can possibly cause a lot more destruction. But the other big thing is that it can also speed up virus production, as people aren't going to have to write it multiple times because of platform-dependent code, or at least it isn't going to have to be as bulky. You aren't going to have to rewrite the same thing 3 different times to target Linux, Mac, and Windows. You write it once, and Rust takes care of it. A big issue is that it makes virus production much more approachable for beginners. Almost as approachable as those little batch scripts that you might see on Windows, where they're like, haha, prank your friends. which is an issue because when you give beginners a lot of power with ease of use, they can pretty easily turn pretty destructive, um, and that's not good to leave that much power in beginners' hands. Thankfully, Rust has already patched most of its issues with opening protected files without actually escalating your privileges, although it has been proven to not be super difficult to escalate your privileges via Rust programs, and Rust is even actually somewhat good at self-modifying programs, so that's another creative issue that you could have. Virus creators can also get more creative, like I said, with a self-modifying program, with the same level of flexibility as C or C++, while being easier to develop and not spending nearly as much time having to learn the ins and outs of every little bit of the compiler and the language. So, big deal, but not necessarily the worst thing in the world. But why would we actually want to choose Rust? There are a couple other languages. Like some of the ones that I picked out off the top of my head for this are Golang, Nim. You might have not heard of that one, or Dlang, also a little bit smaller. Um, some people might just choose Rust because they like the package manager that come Cargo, namely, which allows you to install a lot of packages. They're called crates very easily. Just Cargo install, or even just put it in your manifest file, which is called cargo.toml, and it'll automatically download those crates when you build it. And it has a nice project structure already laid out for you every time you start it. You might just like that. Or to be totally honest, you might be like me and you just like the Rust syntax better than Dlang, Nim, or Golang. Because, they're all cool, but I just personally like how explicit it is with Rust. Um, some people simply don't really like Golang or Dlang. It's not a huge deal. It might just not be your language, even though both could be compiled cross-platform very easily. You might also not want to use Nim, since instead of really compiling, it more transpiles down to C or C++. So if you're unlucky, your virus might end up looking too similar to a previous virus and get detected almost immediately, which would not be very good for a virus builder now, would it? Although it is convenient because since it transpiles down, you can change it to whatever you want, which you can't really do as much with Golang or Rust because editing the IR is a little bit of a nightmare. Personal experience. So, do we actually have any examples of this? And yes, we do. We have a few. I picked out my two personal favorites because they're a little bit cool. In the past, there was a virus called Buer, B-U-E-R, and it was basically spread through emails and would take hold of people's computers, taking sensitive information. And it would always go through Word documents or Excel spreadsheets or whatever. But eventually was caught and basically made obsolete because, well, it was known. Everyone could deal with it. But recently, not that recently as of now, but when I made this recently, there was a new variant that came out called Rusty Buer, which was essentially Buer but rewritten in Rust with a few small changes that didn't change it overall. If you couldn't tell by the link on screen, it was discovered by Proofpoint. We're going to open it, and you can see that it's a new variant. Key findings, Rust, malware, can better evade. It was delivering Cobalt Strike Beacon, access as a service. They would just sell access. We'll see all these photos later. Malware analysis of how it actually works. You can see your Rust dependencies and everything. This is what the bytecode would look like when you actually opened it. So this is what the virtual... It even has its own virtual machine checks. It's got a whole host of things that are very impressive, but because it was rewritten in Rust, it wasn't caught as it was in C. So going back, these are the photos that we skipped over earlier. This is how it's going to be delivered to someone. It'll be sent in the email. In this case, it was delivered by DHL parcel, or supposedly, and it was an Excel spreadsheet, although you'll see it masquerades itself as a Word document. And it's just got some basic info saying you don't have to call, blah, 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 supporting your needs, just trying to bait people into opening the file or downloading the file. Because when you move on, you'll see that it says it's a secure document, it's a protected document, and there's no previewing online protected documents. You have to download them and click Enable Editing from the yellow bar above. A little bit tricky. Hopefully people would see past this, but unfortunately not everyone does. But of course, it's not the only example. We have a few other examples. We have Black Cat, which on forums they're going by ALPHV, ALPHV. They're following the Revil model of offering ransomware as a service. And Black Cat was actually the first to deploy viruses made with Rust in a professional cybercrime cartel. You can see this with this slightly sketchy link, but has nice information on it. You can see that they're on forums. They have cheesy wording, but you can see that it's slowly moving to Rust, and there's a whole lot going on. And you can see that this is the site that people went to. It's got a whole host of things telling you what to do and what they're doing. It is ransomware, so people do have issues with it. When we move on to what it actually looks like, this is what it looks like on the forums. They're saying that they need experienced pen testers. They're bragging about how people have not seen such a level of creation before. And if they want to find out all the details, they need to contact below. As you can see, it was written by ALV online, and with the activity namely being virology and malware. And they're looking for search. This is what the file will look like. Once they steal all your data, this is how they're going to ransom you. You'll see it's pretty generic, but it has worked, and obviously they have their own Tor links. So you never know. You got to be careful because it's becoming more common, even in professional use. So is the malware world actually going to move to Rust, or are these guys just kind of the exception? Personally, I would say absolutely. I wholeheartedly believe that the malware world is going to move to Rust. The speed at which it's moving to Rust is a little bit slower than most people would imagine, but it's definitely moving, and we're seeing it. So now that we've gotten over the basic parts, we want to go over story time, right? Because what's a presentation without a few stories? We're going to go over my experience with Rust, how I would use it, and how I've applied it in areas that could be applicable to virus making if I really wanted to. My personal experience with Rust, personally, I love it. It's very explicit. It's a language where I write once and run it anywhere, which is why for my own little project, which I'm ironically abandoning in favor of C++, which was making a game engine, I chose it. Very easy to cross-compile, can go to anything. But sometimes Rust is a little too explicit, like for a game engine. If we want to talk about how I might use Rust to make a virus, its file system abstraction is very nice, very calm. So I would probably use it to access files, and you can work with the files very easily. It also has a good interface to actually work with operating system specifics. So with a few directives and using some nice little blocking in my code, I can even interact directly with the operating system to escalate my privileges for each operating system in a unique way. And if one fails, you can even make it do it another way very easily. But enough of me just talking about how I might have done this, or how I would, or how I have. How have I applied Rust in a way where I can say that I personally can confirm it could be applicable to virus making? So, if you check my GitHub, which would be in my speaker card, you'll see it's cluttered with a whole mess. But if you look for something called OS Dev Tutoring, you will see the beginnings of a little kernel that I never updated, but I have made a slightly small working kernel in Rust. It's pretty mediocre. It basically just boots. But the point is that you can directly manage memory, and you can get extremely low level. And you can even work without the need for an operating system. Its no STD is very good, which means it works for embedded systems. I also have never pushed them to GitHub because they are a horrendous mess of code, but I have attempted to change some of the Linux kernel modules into Rust, following after the footsteps of some other very smart programmers. I never made it, but a few people have, so the point is that it can easily be applied to Linux, meaning some sensitive systems do run on Linux and can be targeted by Rust very easily. But that is just one of the issues that I've run across and something that I can prove. Now that we have a few closing thoughts, I'll just go over them. I do think that everyone should learn a little bit of Rust. There's no need to be an expert, because I doubt anyone is going to, well, I doubt most people are going to need to be an expert unless maybe you're using it for your job. But you should be aware of what might be coming. It might become a common language, or it might become common at least for virus making, just like C and C++ kind of took off for virus making. Although it might also die and just become a language like Ada, which most people have never heard of. Even though its use in professional environments is happening slower than, say, the adoption of Java or C++, it is clearly being adopted. Some of the companies that used Rust in production include Dropbox, Coursera, Figma, NPM, the package manager. They even brag about it on the Rust site, how NPM uses it. Microsoft, Cloudflare, Facebook, Meta, sorry. Amazon, and even Discord, which is what this con is being planned on. A very convenient little site. I would like to say thanks for listening to this presentation, and if you do have any questions about my presentation, which I'm sure you will have, it's my first presentation. It probably wasn't that great, but if you do have questions, you can always contact me on the Digital Overdose Discord. My name is Sable on there, just like my name. I know, very smart, or rather, not very smart, making my name my Discord user. But you're always welcome to contact me on there. And thank you for listening. I hope that you at least found this presentation slightly informative, or slightly helpful, or even just amusing to listen to. Ciao.